Hey my dear friends, welcome to all. Today we are going to solve the 4 problems in the exercise 6.8. Here the concept is the condition of coplanarity of two lines, in particular non-parallel lines. Okay, and the equation of the plane containing the two lines. Okay, so exercise 6.8 question number 1. Okay, so that the two lines r vector equal to 5i plus 7j minus 3k plus s into 4i plus 4j minus 5k and r vector equal to 8i plus 4j plus 5k plus t into 7i plus j plus 3k are coplanar, and find the vector equation of the plane in which they lie. Okay, just compare these two equations of straight line to the general form. Compare first one equal to some r vector equal to a vector plus sb vector. This one equal to r vector equal to c vector plus t into d vector. So here we are directly getting, you can write comparing with the general equation. A vector equal to 5i plus 7j minus 3k. Okay, so b vector equal to 4i plus 4j minus 5k. C vector equal to 8i plus 4j plus 5k. D vector equal to 7i plus j plus 3k. Okay, so now the condition of coplanarity is either we can write in the vector form or the Cartesian form. So C minus a dot b cross d equal to 0. So first to find out C minus a, C vector minus a vector. So 8 minus 5, 3i, 4 minus 7 minus 3j, 5 minus or minus plus, so plus 8k. Okay, next to find out what is cross product of b vector and d vector. As usual, determine method. First row common and vectors, second row 4, 4 minus 5, third row 7, 1, 3. Just expand this one. So I vector into 12 plus 5 minus j vector into, delete that row and column. So 12, okay, plus 35, okay, plus k vector into, delete that row and column, 4 minus 28. So 17 I vector minus 47 j vector minus 24 k vector. It is b cross d. Now find out what is c minus a dot b cross d. So find out the dot product of these two. So 3 into, okay, so 3 into 17, what is that next, plus 3 into 47, because minus or minus plus, then minus 8 into 24, okay, so what is that, 51, 3 17s are 51, here 1, 141, here 8, 2, okay, remaining 3, so 192, so sum of these two, 192 minus 192, so the value is 0. Therefore the given lines are coplanar. Okay, next our aim is to find out the vector equation of the plane. So vector equation of the plane which contains these two lines. Okay, so that is either r minus a dot b cross d equal to 0, or we can write r minus c dot b cross d equal to 0. Take any one, either r minus a dot b cross d equal to 0 or r minus c dot b cross d equal to 0. I am taking r minus a. So what is a vector? So r minus of 5i plus 7j minus 3k, okay, dot, already we found b cross d, 17i minus 47j minus 24k equal to 0. As usual, take the dot product. So r dot 17i minus 47j minus 24k, okay, this minus, it dot, this one change the side, it becomes plus. So 17 into 5, so 5 7s are 35, remaining 3, 185, okay. So 7 into minus 47, 7 7s are 49, okay, remaining 4, so 28 plus 4, so minus 329, okay, so minus into minus plus, what is that, 324s, 324s are, so 3 into 4, 12, okay, remaining 1, so 72, okay. Now sum up these two, 72 plus 85, so r vector dot 17i minus 47j minus 24k equal to, so what is this two, 157, so 157 minus this value, okay, here 85 plus 72, 157 minus 329, okay, so we are getting minus 172, okay, or if you want to change the side, it becomes plus. So r dot 79 minus 14j minus 24k plus 172 equal to 0. Okay, now question number 2 in the exercise 6.8. So the same, but the equations are given in the Cartesian form, so that the two lines are coplanar. Also find the equation of the plane containing these two lines, okay. So anyway, let's compare with the general equation, x minus x1 by b1 equal to y minus y1 by b2 equal to z minus 4 by z minus z1 by b3. Similarly, x minus x2 by d1 equal to y minus y2 by d2 equal to z minus z2 by d3. If we compare with that, we are getting that x1, y1, z1 as, just change the sign in the numerator, 2, 3, 4. Similarly, x2, y2, z2, just change the sign, 1, 4, 5. And b1, b2, b3 is, look at the denominator, 1, 1, 3, d1, d2, d3. Again from the second one, minus 3, 2, 1. Okay. Now the condition of coplanarity is determine x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 is equal to 0. So now take down the LHS, x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3, which is equal to, so what is that first? 1 minus 2, 4 minus 3, 5 minus 4. 1 minus 2, 4 minus 3, 5 minus 4. Next 1, 1, 3. So minus 3, 2, 1. Okay. So what is the determinant value? Minus 1, 1, 1, 1, 3, minus 3, 2, 1. Okay, just to expand this determinant, first with respect to the first row, minus 1 into, delete that row and column, 1 minus 6, okay, minus 1 into, delete that row and column, 1 plus 9 plus 1 into, delete that row and column, 2 plus 3. Okay, so what we are getting? So minus 5 into minus plus 5. Okay, 10 minus 10 here plus 5. So we are getting 0. 10 minus 10 is 0. Therefore, the given two lines are coplanar. Write it here, write the conclusion. Therefore, the two lines are coplanar. Next, the equation of the plane. Equation of the plane. Just replace x2, y2, z2 by x comma y comma z general. Replace this x2, y2, z2 by x, y, z. We are getting the equation. So x minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3 equal to 0. Simply from the condition of coplanarity, just replace x2, y2, z2 by x comma y comma z. So x minus 2, y minus 3, z minus 4. Or if you want, you can write x minus x2, y minus y2, z minus z2. That is also correct. Okay. And 1, 1, 3, minus 3, 2, 1. So which is equal to 0. So expand with respect to the first row. X minus 2 into, delete that row and column. Okay, I am writing directly 1 minus 6. So we are getting minus 5 minus into y minus 3 into, okay, delete that row and column. 1 plus 9. So 10 I am writing plus z minus 4 into, delete that row and column, 2 plus 3, 5, which is equal to 0. Okay, so divided by minus 5, divided by minus 5, we are getting x minus 2 plus 2 into y minus 3, 2 into y minus 3 minus of z minus 4 equal to 0. So x minus 2 plus 2y minus 6 minus z plus 4 equal to 0. So x plus 2y minus z, so minus 8 plus 4. So minus 4 equal to 0, which is the equation of the plane containing these two lines. In the exercise 6.8, the question is, if the two straight lines are coplanar, then find the distinct real values for m. Listen, distinct real values for m. Both the lines are given in the Cartesian form. As like the previous question, just compare with the general equation. X minus x1 by b1 equal to y minus y1 by b2 equal to z minus z1 by b3, first one. Second, x minus x2 by d1 equal to y minus y2 by d2 equal to z minus z2 by d3. Just comparing with that general equation, we are observing that here the point x1 comma y1 comma z1 is nothing but just change the sign, 1 comma 2 comma 3, and obviously x2, okay, y2 z2 is look at from the numerator, change the sign, 3 comma 2 comma 1, and b1 b2 b3, okay, so 1 comma 2 comma m square. Similarly d1 d2 d3, okay, so which is equal to 1 comma m square comma 2. Given that they are coplanar, okay, so coplanar means determine x2 minus x1, y2 minus y1, z2 minus z1, b1 b2 b3, d1 d2 d3 value is equal to 0. Okay, so find out that x2 minus x1, 3 minus 1, I am writing directly 3 minus 1, 2, 2 minus 2, 0, 1 minus 3 minus 2, 1 2 m square, 1 m square 2, which is equal to 0. Just expand with respect to the first row. 2 into, delete that row and column, 4, okay. So 4 minus m power 4, okay. Then 0, that is not 0 into anything, 0, minus 2 into, delete that row and column, m square minus 2, okay. So it is degree 4th order. So you can rewrite this one as both 2 is here, just leave the 2 if you want, okay. 2 into, so write this as 2 square minus m square the whole square, minus of, so m square minus 2 equal to 0. It is of the form a square minus b square. It is nothing but, okay, a plus b into a minus b. So 2 plus m square into 2 minus m square, a square minus b square equal to a plus b into a minus b, that formula, okay. So minus of, or you can take the minus outside, becomes plus, plus 2 minus m square, okay. I am making a slight change. So now 2 minus m square is common, take it outside. So 2 minus m square into, so here 2 plus m square, here 1, okay. So 2 minus m square equal to 0, or what is that? M square plus 3 equal to 0. M square equal to minus 3, m equal to root of negative, which is not real, okay. Our aim is to find out only the distinct values of real values. So it is not real, okay. So we can leave that one. Square root of a negative is imaginary complex number, okay. So here equate the first one. So m square is equal to 2, m equal to plus or minus root 2. So m can take either plus positive value of root 2 or negative root 2. So the last question, question number 4 in the exercise 6.8. As like the previous question, third question, if the two straight lines are given in the Cartesian form, if they are coplanar, find the value of lambda and also the equations of the plane containing these two lines, okay. Plane equations plural, so we are going to get 2 equations maybe, okay. So obviously just compare with these two with the general equation. We are getting from the numerator x1, y1, z1. So 1 comma minus 1 comma 0, okay. And similarly x2, y2, z2 minus 1 comma minus 1 comma 0. So b1, b2, b3, 2 comma lambda comma 2, d1, d2, d3, 5 comma 2 comma lambda. Obviously we know the condition of coplanarity. So remember the formula. Just put the values, okay. So minus 1, here minus 1, we are getting minus 2, okay. So minus 1 plus 1, 0. So second one is also 0, 0 minus 0. Next 2 lambda 2, okay. And 5 2 lambda. So minus 2 into, delete the row and column, lambda square minus 4 equal to 0, lambda square equal to 4 minus 2, leave that. So lambda equal to plus or minus 2. So either lambda may take plus 2 or minus 2. Now the equation of the plane, or equations mean plural. If you want, you can divide it into 2, okay. So remember that the condition is just replace x2, y2, z2 by x, y, z. So x minus 1, y plus 1, z இங்கே 0 x1 y1 z1 value okay and b1 b2 b3 2 lambda 2 5 2 lambda which is equal to 0 okay so or here also the same x minus 1 y plus 1 z 2 lambda 2 5 2 lambda okay so here if you want to put first if you put plus 2 what we get x minus 1 y plus 1 z 2 2 2 5 2 lambda okay which is equal to 0 so expand with respect to the first row as usual so x minus 1 into delete that row and column sorry here also 2 delete that row and column so 4 minus 4 0 minus of y plus 1 into okay so minus of y plus 1 into delete that row and column 4 minus 10 minus 6 okay 4 minus 10 is minus 6 plus z into delete that row and column again 4 minus 10 minus 6 so divided by minus 6 divided by minus 6 we are getting minus of or divided by plus 6 minus into minus plus okay y plus 1 okay minus z equal to 0 or y plus z y minus z plus 1 equal to 0 the same thing if you put minus 2 here okay so instead of lambda if you put minus 2 so what we get so the same x minus 1 into first 4 minus 4 0 minus of y plus 1 into delete that row and column okay so what we are getting delete that row and column minus 4 minus 10 so minus 14 okay next plus z into delete that row and column okay so what is that delete that row and column so what we are getting 4 plus 10 14 equal to 0 so minus into minus plus y plus 1 plus z equal to 0 divided by 14 okay so y plus z plus 1 equal to 0 okay in the question it is asked equations so we are getting two equations.